Hello class 12th. Today we will start our new chapter, chapter 18, optical instrument. So let's start without wasting any time, the optical instrument. So today's first topic is power of accommodation of eye. Accommodation means to adjust the position, to adjust the focus. For example, this camera is right now focusing on my face, on my body. You are watching me clearly. Now suppose between me and the camera is any object. And now see here. The camera is now focusing on the scale and I am a little bit blurred. Now again the camera can focus on me like this. Now the camera is focusing on me but the scale is a little bit blurred. So this camera lens is adjusting what? The focal length of the lens. So by adjustment of the focal length, it can change the position of focus. Now again you can see the scale. And now on me. So what you have seen? You can focus according to this camera. This camera can focus on the closer object and the farther object. Same way, our eye is having the unique lens which can adjust its focal length. No other lens is able to change its focal length. In this mobile phone, in this camera, there are different number of lenses. They are acting together. That is why they can change the focal length. But a single lens can never change its focal length. The eye is only a lens which can change its focal length. How? Just imagine two different lenses. See here. One lens is thin. Second one is thick. Thin and thick. How you can say which one will have more focal length? By seeing their thickness. The thick lens will have less focal length while the thin will have more focal length. Same way, if our eye can adjust the focus point, so it means our eye is changing its thickness, our eye lens is changing its thickness. So how will it possible to change the thickness of the eye? So for that, see this diagram. In these two diagrams, the first one which can see farther point and the second diagram which can see the closer point in the same position, but the image is forming at same position. Suppose from lens to the object the distance is u, and from the lens to the image point distance is v, and we have the Gaussian form of lens equation, that is 1 upon v minus 1 upon u is equal to 1 upon f. So u and v is in front of your eye. So we can calculate what? The focal length of the lens. But in this second diagram, the u is different but v is same. U is different, v is same. What does it mean? The f will be different. This is in our eye. Our eye is having the same lens. It's not changing the lens, but still the focal point, the image position remains same. In this mobile phone, the focal point is changing because of this phone having the different number of lenses. That is why it can change the focal length. But our eye having only one lens. So how it is changing? By changing the thickness of the lens. How the thickness of the lens is changing? The two ciliary muscles. If you have seen the bio book, the eye is suspended between two ciliary muscles like this, and those ciliary muscles compresses and relaxes the lens. That is why the focal length of the lens change. So if the focal length of our eye will change, so we can focus at different point. So this is called power of accommodation of eye. So again, in short, we can talk about this power of accommodation means the eye lens had different number of focal lengths, a natural lens which can change its focal length, and accommodation is again, suppose you want to see any object which is at far point. Far point means the object is at infinity. Infinity means at long distance. And second thing, if the object is coming closer, so you can focus still. Suppose if any object is coming from very far point, suppose this is my hand. You are focusing on my hand and this hand is coming closer to you. So you can focus on the hand, but there is a limit after which you can't see a distinct. Distinct means different, clear. So that minimum distance up to which you can see clear is called least distance of distinct vision. Clearly remember this. The least distance of distinct vision means if you are seeing the far point at infinity, so the near point is at 25 centimeter. This 25 centimeter is called least distance of distinct vision, means you can see any object clearly from infinity to 25 centimeter ahead to your eyes. So this distance between these from infinity to 25 centimeter from your eye is the distance that you can use your power of accommodation of eye. You can use your eye to adjust its focal length. This is the natural lens which can change the focal length without changing any lens. The only lens in the nature which can change the focal length, that is our eye. No other lens can change the focal length except by mixing of other lenses. Single lens can never change. Our eye can change. So again, if I am talking in this diagram, the first case in which the u and v was fixed, so accordingly the value of f, and in this second diagram the u is different but v is same, means f is different. How it can be possible using single lens in using glass or any material? This cannot be possible, but this is possible only because our eye can change its focal length. This is a very rare thing. The power of changing the focal length of the eye is called power of accommodation. From infinity to 25 centimeter, this is called limit, and the minimum distance up to which our eye can see, that is called least distance of distinct vision, that is 25 centimeter. Moving to our next topic, that is called visual angle. Suppose you are standing at 4th floor of a building and you are watching any object at floor, means at the ground floor, and the object length is 10 meter. So I think you can see that 10 meter at single sight. But second case, suppose that scale, but that rod is just in front of your eye. So are you able to see the 10 meter rod just at one glance? No. You will see how? You will see the top and then you will go to the bottom of the rod. But when it was at the ground floor, then you were able to see. Same way, you are standing anywhere and you are watching any tree. So at one glance you can see whole the tree. But suppose you are under the tree. So what you will see? You will see the top of the tree, then the bottom. Same object. Why this image size is different? Because this is all about the visual angle. In visual angle, if you will say, suppose, see, the eye is focusing at any object, O dash. Suppose the height is h. And due to this visual angle, theta, on the retina, what you are seeing, the image, suppose II dash, or you can say PQ. The same object is moving closer to the eye. And now, see, what is the visual angle? That theta has been increased. Suppose that is any other symbol. Suppose that is
beta.
then you can see the size on the retina of the image is increased. So same object is making different visual angles on our retina. So depending on the size of the image on retina, we are able to see the objects. See this hand, you can see clearly. Now, I think when I put the complete hand on the camera, you can't see anything because this is closing the visual angle. So this visual angle, whatever it is making on your eye, visual angle of this hand, whatever it is making on your eye, if I am putting close, so visual angle increasing, that is why the size of the hand you will see are increasing on this screen. Same way on our eye retina. Retina is as a screen for our brain. So whatever we are seeing, watching, that size, if that object comes closer, so visual angle increases, so we can see the bigger and bigger object. And suppose the object is coming closer or moving farther, if the eye has some problem, so the person can say that I am able to see closer object but not the farther object, or the vice versa. But what a person is using to cure his eye problem? The specs. On using this specs, suppose the visual angle was not able to form the image on retina. On using these specs, so now the visual angle is forming at our eye. So that at this time we are able to see the object. So it is what? The instrument which makes the object to form the image on the retina, and it is adjusting what? The visual angle. So the next topic is called magnifying power. So magnifying power, it is defined as the magnifying power of an optical instrument is the ratio. Remember, it's a ratio of the visual angle subtended on eye by image using instrument, optical any instrument, using instrument, the visual angle formed by image on eye with instrument to the visual angle formed by the object without any instrument, or you can say with unaided eye. What said? It is the ratio of visual angles subtended by image on the retina using instrument to the visual angle subtended by the object. Angle by image, angle by object. Angle of image used found by the instrument, and the angle by the object. The visual angle by image found by instrument to the visual angle of object without any instrument. This is all about the magnifying power. So the visual angle has some symbols. The visual angle formed by image with instrument is symbolized by beta, and visual angle of the object with unaided eye is symbolized by alpha. So magnifying power has symbol capital M. So capital M is equal to beta upon alpha. Beta is the visual angle formed by image on eye using instrument. Alpha is the angle, visual angle formed by object without any instrument. So let's move to our next topic, simple microscope. So starting with simple microscope, but I want to inform you in this chapter there will be simple microscope, then compound microscope, then astronomical telescope, microscope and telescope. So if we are going to start the simple microscope or any microscope or telescope, I want to inform you what we will obtain. We will obtain the magnifying power, means we will calculate the ratio of visual angle beta with visual angle alpha. Same way here we are going to do. But first of all, what is simple microscope? This is nothing but the sixth case of image formation using convex lens. See here. In this case, the object is in between the optical center and the focus of the lens. So the image is formed erect, virtual and a little bit magnified. At this time, beta is the visual angle using this lens for that eye. Beta is the visual angle using this lens, because I said using the instrument. Here instrument is what? A lens. So beta will be the angle here using that instrument on the eye for this image. So same angle for the image and the object both. So what will be beta here? If beta is very small for visual eye, the small aperture, so beta is very small, so we can say beta is equal to tan beta. So what is tan beta here? Object size upon the object distance to the optical center, or you can say if the object size AB, so AB upon OA. This is what? The visual angle with instrument. And now without, because I said the magnifying power is the ratio of visual angle with instrument to the unaided eye. Now remove that lens, and the minimum distance, what I said, the minimum distance where the image can be seen clearly, that is called least distance of distinct vision, symbolized by capital D. Now see this. In this diagram, the object is seen without any instrument, and the minimum distance will be capital D. For a normal healthy person, this is 25 centimeter. So I am naming just capital D, nothing else. So capital D distance this instrument is, this object is. So now this angle will be alpha because it is unaided eye. So Alpha again is very small, so alpha is equal to tan alpha. Tan alpha will be AB, same, upon the D, object distance, or you can say again OA. So let's calculate the magnifying power of this lens in the sheets. First, understand the magnifying power. This is the ratio of visual angle subtended by image by instrument to the visual angle subtended by object unaided eye, means without any instrument. So this is clear now. Simple microscope, see here. For simple microscope, a lens, in front of that any object AB at position between focus and optical center. So first ray toward the focus, second from optical center straight. So you can see it is diverging. So let's produce backward to form image. Here you can see the image is formed virtual and erect. This image is formed with instrument. Suppose I am watching from here. So this image is formed with instrument. So this is added eye. So this will be beta. So angle is so small. I am writing here. Angle is so small. So beta is equal to tan beta. So tan beta here, the visual angle formed by image. So this angle beta for this and this both. So beta I am writing here AB upon AO. So here beta calculated, the visual angle subtended by image with instrument. So this is with instrument. Now without any instrument, let's draw. Now without any object, same object, without any instrument, same object AB is visualized from here. So with instrument it was symbolized with beta, and without any instrument it is symbolized with alpha. This is also called unaided eye. See here, visual angle subtended by object unaided eye. This is unaided eye. So here again alpha is so small, so alpha is equal to tan alpha as it is here. And this distance is called least distance of distinct vision, symbolized by capital D. So writing here perpendicular upon base. And this ratio of the visual angles subtended by this instrument and object unaided eye is what? Magnifying power. Let's calculate here. According to definition, magnifying power is equal to beta upon alpha or tan beta upon tan alpha. And their values AB upon AO, AB upon D. AB will be cancelled. So after cancelling AB, what is remaining? D upon AO. What is AO right now here? So see here, what is AO? AO is the object distance, and the object distance has symbol U. So we can write here what? That D is equal to, M is equal to D upon U. So M is equal to D upon U is the expression for the magnifying power of simple microscope. This is in terms of least distance of distinct vision and the object distance. If we have to write this in terms of focal length of the lens also, so let's see what to do. For that I am using this equation. Where is the image is formed? Image always formed at least distance of distinct vision, means this is complete capital D. Always, whenever the image is formed, means this image is at least distance of distinct vision. So instead of 1 upon V, I am writing 1 upon minus D, because it is on left of the optical center, minus 1 upon U. U is also on the left, so minus U is equal to 1 upon F. We have to calculate in terms of that. So here it is D by U. If I multiply with D here in the numerator, so what will be here? See here, on multiplying with D, so D upon minus D minus D upon minus U is equal to D upon F. So this D is cancelled, this minus become positive. So minus 1 plus D by U is equal to D by S. And D by U is what? D by U is what? The magnifying power. So let's write first. So minus 1, because D is cancelled, minus 1, this becomes positive. D by U is equal to D by F. Or again, D by U is equal to 1 plus D by F, because this minus going to that side. And D by U is what? The magnifying power M. Again, right? So we have the another equation. The magnifying power in terms of D, least distance of distinct vision, and the object distance. And different thing is in terms of least distance with focal length. One more case, suppose this object is shifted to the focus, at focus. If this will be at focus, so image will form at infinity. So if image is formed at infinity, so value of u is what? Value of f. This is what? This is our focal length. If suppose this object is moved to this place, so the object distance u will be what? The focal length f. At that time, what will be the equation? This d by u. So I am writing here the last case. Understand this. When object is at f, this object is shifted to the focus. Means when object is at f, this situation is called relaxed eye. In that case, u change to f. So what will be m? Let's start here. At that time, m will be equal to d by f. When object is at f means relaxed eye case. So this is normal situation and this is relaxed eye situation when object will be at focus. In all the instrument, we will study the same thing. We will calculate the magnifying power, then we will calculate the magnifying power when the object is at. Here I am ending this session. In the next lecture, I will discuss about the numerical and something more. If you will comment me, if you will inform me your doubts. Till then, take care and thank you.